Hello students, welcome back. So in this video lecture we are going to see convolution theorem and use of the convolution theorem to solve problems. So convolution theorem is helpful when the methods that we had studied in the last video lecture all fails to give an answer. So this method is very useful to find the inverse of product of two functions, Laplace inverse of two functions. So mainly we are going to deal with the statement and we are not interested to see the proof of this theorem. So let's see the statement of convolution theorem. What is mean by this? If Laplace inverse of f of s is equal to f of t and Laplace inverse g of s, another function of s, is equal to g of t, then Laplace inverse of product of f and g is equal to integral 0 to t f of u into g of t minus u du. So here f of u comes from this f of t, g of t minus u comes from this g of t, where f of u is obtained from this f of t by replacing t with u, okay, and this g of t minus u is obtained from g of t by replacing simply t by t minus u, okay. So we are dealing with f of t, g of t. We are not interested in this f of s and g of s, okay. So you have to just replace the values of t here by u and here t by t minus u, okay, simply. So let me introduce one problem. Evaluate using convolution theorem L inverse of 1 upon s square plus 1 into s square plus 9, okay. So these are the product of two functions. Let me write in the solution. First one is function of s and is given as f of s equal to 1 upon s square plus 1, and second one is g of s equal to 1 upon s square plus 9, okay. Here Laplace inverse of f of s is 1 upon s square plus 1 equal to sin t. Sin t is nothing but here f of t, okay, and L inverse 1 upon s square plus 9 is nothing but 1 upon 3 sin 3t, which is nothing but g of t, okay. So our definition or statement of this theorem, we have this is f of t, this is g of t. So using these two functions we are going to change f of u and g of t minus u. So instead of writing f of u, I would like to write sin u here, and instead of writing sin 3t, I would like to write here sin 3t minus 3u divided by 3. So 1 by 3, so it is 3, and sin 3t is nothing but t is replaced by t minus u, so therefore 3t is nothing but 3t minus 3u. So let me write 1 upon 3 outside, and value of sin u into sin 3t minus 3u is nothing but 1 upon 2 into cos u minus 3t plus 3. So this is because of cos a minus b and cos a plus b, okay. Remember those formulas and write the value, okay. Now 1 by 3, so this 1 upon 2 is constant, so let me take it outside, and 1 by 3 into 1 by 2 is 1 by 6, integral 0 to t. So cos u plus 3u is 4u here, and minus 3t as it is. Now cos, so minus cos u plus 3t minus 3u is nothing but cos 3t minus 2u, okay. Now let's see. So 1 upon 3 into 1 upon 2, 1 by 6 here I have written. So integral of cos 4u minus 3t with respect to u and cos 3t minus 2u with respect to u is given here. Sine of 4u minus 3t divided by 4 minus sine of 3t minus 2u divided by minus 2. So minus 2 comes from this and here 4 comes from this. So limits from 0 to t. So 1 by 2 into 1 by 3 is equal to 1 by 6 and is nothing but sine 4u minus 3t divided by 4. Here it is minus and here it is minus, so becomes plus sine 3t minus 2u divided by 2, 0 to t. Now is equal to 1 by 6 into, so put upper limit. So as u is equal to t, therefore sine 4t minus 3t is t by 4 plus sine t by 2 minus lower limit minus sine minus 3t by 4 minus sine 3t by 2. So as we have sine is odd function, therefore sine minus 3t is equal to minus sine 3t, and here it is sine t by 4 plus sine t by 2 is nothing but 3 sine t by 4. Here it is plus sine 3t by 4 minus sine 3t by 2. So it will reduce us to 1 by 6 into 3 sine t by 4 minus sine 3t by 4. So we'll take 4 as common, 1 by 4 common. So it will 1 upon 24 into 3 sine t minus sine 3t. Therefore final answer is this. L inverse 1 upon a square plus 1 into a square plus 9 is nothing but 1 by 24 3 sine t minus sine 3t. Okay, so we'll look for one another example. For simplicity we may take different function. Now question is L inverse of s divided by a square plus 4 into a square plus 9 is equal to question mark. Okay, that means we have to find the value of this L inverse. So let f of s is equal to s divided by a square plus 4 and g of s is equal to 1 upon a square plus 9. Okay, here L inverse s upon a square plus 4. So first function is I have taken here s divided by a square plus 4 and second one is, okay, so fs into gs is s by a square plus 4 into a square plus 9. Okay, so without loss of generality of this function we may take two different functions as f of s is equal to s divided by a square plus 4 and g of s is equal to 1 by a square plus 9. Here Laplace inverse of first function is cos 2t that we have studied in the previous video lectures, and L inverse 1 upon a square plus 9 is equal to 1 by 3 sine 3t. Okay, by convolution theorem, what does it says? L inverse f of s into g of s is equal to integral 0 to t f of u g of t minus u into du. Okay, now let's see what is mean by this. So L inverse s divided by a square plus 4 into a square plus 9 is equal to integral 0 to t. So first one is f of u. F of t is nothing but cos 2t, and hence f of u is equal to cos 2u, and g of t is equal to 1 by 3 sin 3t, hence g of t minus u is nothing but 1 by 3 sin 3t minus 2u 3u into du. So let me take 1 by 3 outside, and integral 0 to t is cos 2u sin 3t minus u into du. Okay, but we know that sin a plus b and sin a minus b. What is sin a plus b? Sin a plus b is nothing but sin a cos b plus cos a sin b. Okay, now sin a minus b is equal to sin a cos b minus cos a sin b, but we have here cos into sin. So I would like to perform subtraction between these two. So sin a plus b minus sin a minus b is equal to sin a cos b, and minus sin a cos b is equal to 0 here, plus cos a sin b minus minus plus cos a sin b, 2 times cos a sin b. So cos a sin b is equal to 1 by 2 sin a plus b minus sin a minus b. So using this fact, I have written here L inverse s divided by a square plus 4 into a square plus 9 equal to 1 by 3 integral 0 to t 1 by 2 sin 3t minus u minus sin 5u u minus 3t into du. Now separate the integrals and write the integral value of this. So sin 3t minus u, integral of sin 3t minus u is nothing but minus cos 3t minus u divided by minus 1 minus minus cos of 5u minus 3t divided by 5u. So limits from 0 to t. Now here it is minus and here it is minus, so it will become plus. Now here it is minus 1 and here it is minus, so it will become plus. So 1 by 6 into cos 3t minus u plus cos 5u minus 3t divided by 5, limits from 0 to t. Put upper limit and then the lower limit. So if we'll use u equal to t, then it will cos 2t plus cos 2t by 5 minus lower limit, then cos 3t minus cos minus 3t by 2. As we know that cos is even function, hence cos minus 3t is equal to cos 3t plus 3t. So let me combine these things. So cos t plus cos 5 cos 2t by cos 2t plus cos 2t by 5 is nothing but 6 by 5 cos 2t, and along with this negative sign, cos 3t plus cos 3t by 5 is nothing but 6 by 5 cos 3t. So 6 by, if you take 6 by 5 common, then the rest thing is in front of you, and that will be 1 by 5 cos 2t minus cos 3t. So this is the final answer. Okay, so let me stop here. We will see more examples on this point in the next video. Okay.